Okay, class. Whoa, what happened? Can I move this? I can move that. Go away. We're going to learn about scientific. Let's start. Notation.
Okay.
That's okay. Scientific notation. I need my notes. Sorry. And where should I stand? I'll stand over here. Okay. So, scientific notation is a way to express very big numbers. What is it? It's a way to express very large numbers, okay? And we use that a lot, so it would be a number of the form a times 10 raised to the nth power, okay? And if you're expressing very large numbers, then this n is a positive power of 10. And if you're expressing very small numbers, then you use negative powers of 10. So a has to be a number which is greater than or equal to 1 and less than 10. That's what that means. So that number has to be a number like 1 point something or 2 point something or 3 point something or 4, but you can't have a scientific notation that begins with a like 10 point something. Okay? So, can anyone think of anywhere where you would have to use scientific notation to express very large numbers?
37.
Like, where do you see very large numbers? In space, right? Distances to planets and stuff like that. The national debt, you know, they talk about the national debt being trillions of dollars.
It just reached
Okay. How many trillion?
14.5 trillion.
14.5 trillion. So if I have 14.5 trillion, okay, that's not in scientific notation. That's something that's easy to say. But what that means is a million has how many zeros? 6 zeros, right? So
It has 9 in the trillion.
that's this would be a million, right? This would be a billion over here. So a trillion, and then it's 14.5 trillion. So that would mean that you would have like a 1, 4, and this number right here would be a 5. So that number is 14.5 trillion. Okay? So maybe if I were a politician and I wanted to talk about how big the national debt was, I might want to express it like that rather than say, oh, it's just 14.5 trillion, right? So very large numbers like that. And the way I would write this in scientific notation is to start at the very end of the number and count how many places it is until I get to here, okay? So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I could write this number in scientific notation as 1.45 times 10 to the 13th power. Okay? And that's writing that number in scientific notation. Okay? So we just talked about the national debt, Ms. Lindgren. Okay? And Freddie told us that it's $14.5 trillion. And so we wrote that number, and we wrote out what 14.5 trillion is. And then we wrote that number in scientific notation. Pretty good. Can anyone think of anywhere where we would have a really, really, really small number?
Oh, 0.0000001%.
Well, yeah, but anyone in science, have you talked about like the weight of an atom or something like that?
That's a good one.
Okay? But if they weigh atoms, those have very, 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 very small numbers. Okay? And I'm not sure what it is, but something like 0 with like, it's got like 23 zeros before it or something, some really tiny the atomic weight of a carbon atom or something like that.
I think you might be talking about hydrogen.
I don't know, or hydrogen, I forget my science. But you might have a number like 2.3 times 10 to the negative 20 power or something like that. And what that means is you would go the opposite way 20 places and put 20 zeros in front of it. So, well, not 20 zeros, you'd actually put 19 zeros because you'd move 19 places or 20 places this way. Okay, so you'd only be adding 19 zeros. So that'd be 0.000. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 2, 3. Okay? So that would be that number, because from here to here, it's 20 places. Okay? So that's 2.3 times 10 to the negative 20th power. And those numbers do come up when you're dealing with subatomic particles and stuff like that, or atomic particles. All right. So, so we talked about some scientific notation. Is this number in scientific notation? 52 times 10 to the 6th? Is that scientific notation?
Yes.
Yes.
No. Okay? Because it has, this number in front has to be between 1 and 10. Okay? So I could write it in scientific notation, and this is the way I think about it. Okay? Did this number get smaller or bigger when I did that? So what has to happen to this number?
Bigger.
It has to get bigger by 1. Okay? So now that thing is in scientific notation. So if this number gets smaller, this quantity has to get bigger. Okay? And that's how I kind of remember it myself. How about this one? 0.375 times 10 to the 6th. Is that scientific notation? No.
No.
Because this number has to be a number between 1 and 10. So I have to move the decimal place to the right, to make it into 3.75. Did this number get smaller or bigger?
Bigger.
Bigger. So what has to happen to this? Smaller. 10 to the 5th. Now it's in scientific notation. Okay? What if I had something like new page? If I get a new page. Oh, I can't see my pages. New page. What if I had where's my number? Point 0.00000375. And I say write in scientific notation. Write, that says write. Write in scinot. Who wants to do that for me? Alec, can you do that for me?
Yeah, so you're gonna have to make it bigger. I mean, no, it's gonna be negative.
That's right, but how many places do I have to move this decimal point?
5.
1,
6, I mean 6.
2, 3, 4, 5, 6.
Yeah.
So I'm going to write this as 3.75 times 10 to the
Negative 6.
negative 6. Very good. Because this number got bigger, so whatever I'm multiplying by has to get way smaller. I was multiplying by 10 to the 0, which would be 1, right? So I make this into 10 to the negative 6. Or you could just know I moved my decimal place 6 places to the right. What if I say write in expanded form? So what if I want to go the other way? Write in what do they call it? Not expanded form. Standard form. And I have tell me how to do that? Other than Fred. Michael, can you tell me how to do that? 3.2 times 10 to the fifth?
Well, would you do 10 to the fifth first?
No. Just move the decimal place. How many places should I move that decimal place?
5.
5. Which way?
Um,
Is this a big number or a small number?
Big
Big number, so which way does the decimal place move?
to the right.
To the right. So what was 3.2, I'm going to go 1, 2, 3, 4, 5 decimal places and put a point there, and I'm going to fill in zeros, okay? So I moved 5 decimal places, so that number is, then I could go back and put in the commas, 320,000. That's what it means, 3.22 times 10 to the fifth. Okay? Yes, sir. Fred, did you have a question?
No.
Real world masses of atoms, we talked about that. A neutron.
No.
A neutron is 1.674 times 10 to the negative 24th power. That's pretty small. An electron is 9.1. An electron weighs 9.1 times 10 to the negative 28th power. Wow. How many electrons would I have to have a pound of electrons?
Too many.
A lot, okay? But if I want to write this, what would I do? How would I expand that? How would I expand that? Which way would I go? Which way? Left, how many places? 28 places. So you go like this, 28 decimal places. How many zeros would be in front of the 9? 27 zeros in front of the 9. Whole bunch of, right? Anyway, you got the idea. Very, very, very small number. Okay? Then you're going to see some things like this. Next type of problem you're going to see. They'll say, write, so 7 times 4 times 10 to the 6th, okay? So say Mr. Rich is going to give 4 times 10 to the $6 to all of his 7 grandchildren. How much money is he going to give away? And write that in scientific notation. So if I multiply something like this, I go 7 times 4, which is what? 28. And when I do multiplication, I don't distribute. I just multiply things times itself once. But then this is not in scientific notation. How can I write that number in scientific notation? Fred, go ahead.
Decimal point
2.8 times 10 to the
7.
good. Okay, times 10 to the 7th. Because this is, I made this number smaller, so this number needs to get bigger, right? Okay. What if I had, it gets a little tricky. What if I had 0.37 times 10 to the negative 6th, okay? And I say write in scientific notation. This is where people get a little bit confused. What would go in front? What would go in front? Busy. What would go in front up here? What do I have to change this into? Where does that decimal point need to go? Between the 3 and the 7. So I'm going to go 3.7, okay, times 10 to the, did this number get bigger or smaller? It got bigger, right? 0.37 is smaller than this. So this has to get bigger or smaller? Smaller. What is one place smaller than 10 to the negative 6th?
-7.
Yeah, don't say negative 5th, right? That needs to go down to negative 7.